Hello guys. Today, we're looking at a problem-transformed array. Let's break it down in simple terms. You are given a list of numbers called nums. Imagine this list as a circular array, which means if you go past the end, you wrap around to the beginning, and if you go before the start, you wrap around to the end. Your task is to make a new list called result of the same size as nums. Here's what you do for each number in nums. If the number is positive, nums of I greater than 0. Start at position I. Move to the right by that number of steps, wrap around if needed. Set result of I to the value at the new position. If the number is negative, nums of I less than 0. Start at position I. Move to the left by the absolute value of that number, wrap around if needed. Set result of I to the value at the new position. If the number is 0, nums of I equals 0. Simply set result of I to 0. Finally, return this new list result. Example in words. If your list is 2, -1, 0, 3. Start with 2 at index 0, move 2 steps right, land on value 0. For -1 at index 1, move 1 step left, land on value 2. 0 stays 0. 3 at index 3, move 3 steps right, wrap around and land on value -1. And that's it. You've transformed your array according to the circular rules. Example 1. Input array is 3 2 1 1. Indexes are 0 1 2 3. Now let us go element by element. At index 0 the value is 3. Since the value is positive we move 3 steps to the right. Starting from index 0. First step goes to index 1. Second step goes to index 2. Third step goes to index 3. At index 3 the value is 1. So result at index 0 becomes 1. At index 1 the value is -2. Since the value is negative we move 2 steps to the left. Starting from index 1. First step goes to index 0. Second step goes to index 3 because the array is circular. At index 3 the value is 1. So result at index 1 becomes 1. At index 2 the value is 1. Since the value is positive we move 1 step to the right. From index 2 we reach index 3. At index 3 the value is 1. So result at index 2 becomes 1. At index 3 the value is 1. Again we move 1 step to the right. From index 3 we wrap around and reach index 0. At index 0 the value is 3. So result at index 3 becomes 3. Final output array for example 1 is 1 1 1 3. Example 2. Input array is -1 4 -1. Indexes are 0 1 2. Now let us process each element. At index 0 the value is -1. Since it is negative we move 1 step to the left. From index 0 we wrap around and reach index 2. At index 2 the value is -1. So result at index 0 becomes -1. At index 1 the value is 4. Since it is positive we move 4 steps to the right. Starting from index 1. Step 1 goes to index 2. Step 2 goes to index 0. Step 3 goes to index 1. Step 4 goes to index 2. At index 2 the value is -1. So result at index 1 becomes -1. At index 2 the value is -1. We move 1 step to the left. From index 2 we reach index 1. At index 1 the value is 4. So result at index 2 becomes 4. Final output array for example 2 is -1 -1 4. Let us first look at the code. We have a function called construct transformed array. It takes an array called nums as input and returns a new array. The entire logic is written in a single line using list comprehension. Now let us break it down slowly. The main idea of the problem is simple. For every index in the array, we need to move either left or right based on the value at that index. Since the array is circular, we use modulo operation to handle wrapping. Inside the list comprehension, we loop through each index I from 0 to the length of the array -1. For every index I, we calculate a new position using this expression. I plus nums at index I modulo length of nums. This expression is the heart of the solution. Let us understand why this works. If nums at index I is positive, adding it to I automatically moves us to the right. If nums at index I is negative, adding it to I automatically moves us to the left. So we do not need separate conditions for positive and negative values. Now comes the important part. The modulo operation ensures circular movement. If the calculated index goes beyond the last index, modulo brings it back to the beginning. If the calculated index becomes negative, modulo automatically wraps it to the end of the array. This is exactly how circular arrays work. After calculating the new index, we simply pick the value from nums at that position and store it in the result array. This process is repeated for every index. Finally, the list comprehension returns the fully transformed array. Okay, let's run the code. And yeah, all test cases passed successfully. Let's submit the code. And yes, it's passed against all the hidden test cases. That is how you solve the transformed array problem, using a clean one-line Python solution. If you understand this approach, you will find many circular array problems much easier. The solution link is in the video description. Thanks for watching. See you in the next video.